Hello viewers, in this tutorial we will continue with finding support reactions. Of course, this is the continuation of tutorial number 4, wherein we have introduced several problems of interest, of engineering interest, but very simple in nature. In this tutorial we will just move on to moderate complexity problems or problems with moderate complexity. Of course, they are support reaction problems only. If we recall our memory, in a non-concurrent force system that is in equilibrium, we have to press three equations into service: sigma fx equal to 0, sigma fy equal to 0, and sigma m with respect to a specific point should be equal to 0. Right. Find support reactions for the beam shown. This is the problem, and here is the beam, and here is an inclined load. It will have an horizontal component like this, which is 60 cos 30. Therefore horizontal force exists in this beam, over this beam. Therefore there is a horizontal reaction which is acting in a positive direction at the hinge support, and here it's a roller support which will experience always a vertical reaction. So now, and here is a ready-made moment or concentrated moment which is acting clockwise nature at a distance of 1 meter from the right support, and this is RA and this is RB. Now we will apply sigma fx equal to 0, and we will have HA going horizontally minus 60 cos 30 coming in this direction, leftward direction, and therefore we got HA equal to 51.96 kilonewton, and the value is positive. Therefore our assumption is correct as far as the direction of this reaction is concerned. Sigma Fy equal to 0 will give us RA, RB going up, upward forces equal to downward forces. It is 40, and this is 60 sin 30, and there are no other vertical loads acting over the system. Therefore RA plus RB equal to 70. Now we need to take moment with respect to A. Then we have to release this support and apply this particular reaction, that is RB. So RB is anti-clockwise. RB into 1 plus 1.2, 2.2 plus 1.5, 3.7 plus 1, 4.7. So RB into 4.7. All the anti-clockwise moments should be equal to clockwise moments. So this is 40 into 1 moment arm, clockwise moment, 60 sin 30 into 2.5, 1.5 plus 1, that is the moment arm, plus 10 a readily available concentrated moment. This will give us RB equal to 125 divided by 4.7, that is 26.6. And when we substitute the value of RB over here, we will get back as to what RA is. Therefore RA is 43.4 kilonewton. Now here is another beam which is being superimposed with a concentrated load and a UDL and an inclined load. Due to the presence of this inclined load, 60 cos 45, a force acting rightward direction, immediately there is a reaction that is being set up in this direction. Here again we can assume this to be positive, and the system will adjust during that time. During that particular process, this reaction may become negative. Then it is very easy to reverse the direction. Here by intuition we have placed this particular reaction to going to be leftwards, because the active force of the horizontal component of 60 kilonewton is rightwards. Now we will apply sigma mb equal to 0. It's better we start with the taking moment of all the forces with respect to a support, because we will readily get one of the unknowns solved. So here sigma mb equal to 0, therefore RA into 2 plus 4 6, 6 plus 1 7, 7 plus 2 9. So RA into 9, a clockwise moment, minus 20 into 4 plus 1 5, 5 plus 2 7. This is anti-clockwise. And 30, and this is 30 into 4, because this is 30 kilonewton per meter spread over 4 meters. Therefore equivalent concentrated load, this is the red force which is acting downwards, is 30 into 4, and the moment arm for this with respect to B is here 2 meters plus 1 3, 3 plus 2 5, and minus 60 sin 45 acting downwards into 2. This is the moment arm. So this will get us RA equal to 91.65 kilonewton. and when we apply sigma fx equal to 0, we will get 60 cos 45, the horizontal component of 60 acting rightwards, minus hb, the assumed reaction this way. We will get hb equal to 42.43 kilonewton. Since we have got the positive value, our assumed direction of hb is correct. And sigma fy equal to 0 will give us ra plus rb, ra plus vb, of course vertical reaction, because there are two types of reaction over here. We chose to write this force to be vb, that is vertical force at b. So 20 force 30 into 4 equivalent concentrated load plus 60 sin 45. So this will get us vb equal to 90.8, because we can directly substitute 91.65 gotten in the very first step itself. Therefore vb equal to 90.8 kilonewton. Now we will move to next problem. It is cumulatively numbered, of course. Here there is a presence of triangularly varying load over the overhanging portion, and this is the equivalent concentrated load, 24 into 3, acting exactly at 1.5 meter from this end or 1.5 meter from that end. And here sigma ma equal to 0, so 30 into 1, 30 into 1, that is this one, 30 into 1, sigma ma equal to 0, and 24 into 3, the equivalent concentrated load, into 1.5 plus 1, 2.5 plus 1, 3.5. So 2 plus 1.5, 3.5, plus this area of the triangularly varying load itself is the equivalent concentrated load, that comes like half, base is 1.5, height is intensity of loading 40 kilonewton per meter. Therefore meter will cancel away, and we will be getting 60, that is 20 into 1.5, that is 30 kilonewton here, acting here at a distance of 1/3 of base, 1/3 of 1.5 meter, or 2/3 from this apex, 2/3 from here or 1/3 from here. So 1/3 of 1.5 is 0.5 meter. Anyway, we have written directly over here, and we are taking moment with respect to this. Therefore 1 plus 1 plus 3, that is 5 plus 1.5 by 3, this distance will give us the momentum for this equivalent concentrated load owing to the triangularly varying load, minus ra into 5, ra into 5. Yeah, it should be rb into 5. Of course we will make it rb into 5, and here also it is rb into 5, here too it is rb into 5. Right here it should become ra, because we have already solved for, so we will sorry for this minor correction, and here it is ra. Yeah, so solved. Now we'll go back again, right. So we have got the value of rb to be 89.4, and fy equal to 0 will give us ra plus rb equal to minus 30, minus 24 into 3, equivalent concentrated load, minus half into base into height, that is triangularly varying load, and we got ra to be equal to 42.6 kilonewton. Right. Determine the reactions developed at supports A and B of a single overhanging beam. It is a single overhanging beam. Here is a piece of the beam protruding beyond the simple support. This is a simple span. This is a simply supported span, and beyond this it becomes a single overhang. And here it is subjected to a concentrated moment and an inclined load and a UDL. If the presence of inclined load will definitely generate a horizontal force over here, and we have assumed to be positive, and it is justifiably so, because this force will be having an horizontal component going leftwards. It is 30 cos 45. So let us see. And here is the equivalent concentrated load acting exactly at 1 meter from this support. Right, sigma fx equal to 0 will give us HA positive minus 30 cos 45, the horizontal component of 30 kilonewton. We will get HA equal to 21.21. Sigma MA equal to 0 will give us RVB into 3 plus 2 plus 1, 6. Yeah, VB into 6 anti-clockwise, 40 readily available concentrated moment, and 30 sine 45 the vertical component of this 30 kilonewton load, and it has a distance of 3 plus 2 5, and it will produce a clockwise moment with respect to A. And 20 into 2, this is the equivalent concentrated load, into 7, because this is 1 and this is 6. 6 plus 1 7 minus VB into 6. This will get us VB equal to 71.01 kilonewton, and sigma Fy equal to 0. We will equate all the vertically upward forces to downward forces. So VA plus VB, the two vertical forces at two supports, minus 30 sine 45 coming down, minus 20 into 2 coming down. So this will get us a value of VA to be minus 9.79 kilonewton. So our assumed direction going up is the vertical force going up, reaction going up is wrong. Therefore we will just remove this and we will put up with the correct force, the correct force with the directionality. Now a double overhanging beam 20 meter in span supporting UDL intensity of 6 kilonewton per meter, and also with two concentrated loads of 30 kilonewton here and 50 kilonewton here at either extremities. How far the support A is to be located? Support A is to be located from C, from here, such that both the reactions are equal. Now it is given RA equal to RB, and this is the equivalent concentrated load, 6 into 20 meter span, 120 kilonewton. It will be acting exactly at 6 meters from this support or 6 meters from that support. So sigma Fy equal to 0 will directly give us VA vertical force plus VB, and there is no chance for any horizontal reaction over here because all the forces are vertical in nature. Minus 6 into 20 equivalent concentrated load, minus 30 and minus 50. So that will get us as per the condition VA equal to VB. Then we will substitute that, it will become 2 times VA equal to something, and we will get VA equal to VB equal to 100 kilonewton. Now same force, same thing, we need to find out one of the reactions. Therefore we will take moment with respect to C equal to 0. We cannot take moment with respect to this because we don't know this unknown, and we don't know this, we don't know other things. This distance is also not known, so known to us the entire span is known. Anyway, moment about any point over a structure should be equal to 0 in order that the structure should be in equilibrium. So minus VA into X, this is the X, and we are taking that is anti-clockwise moment, minus VB going up into 12 plus X, okay, that is the moment arm, minus 6 into 20, 120 into 10, and this distance is known to us because it is half of 20, minus 50 into 20, this is 50 into 20. Anyway, this force cannot create a moment because it is acting right at C. Now we will get with this X equal to 5 meters. Okay, so a simple equation sigma MC equal to 0 would have given us has given us X equal to 5 meter, and had we taken moment over here, the problem solving would have become cumbersome because we don't know this distance, right? Find the magnitude and the direction of the support reactions at A and B for the beam shown. This is similar to the previous problem, excepting the fact that here the support itself is rotated. The roller support itself is rotated. Whether it is rotated or not, okay, the direction of the reaction at the roller support is well known to us. It is always perpendicular to the plane of rollers. This is the plane of rollers. The plane of rollers has been inclined at an angle of 30 degrees with respect to horizontal. Therefore, the reaction over here will be like this, perpendicular to the plane of the roller. So this angle is 90 degree. Therefore, this is 30 degree. Okay, if the inclined plane makes an angle of 30 degree, the perpendicular to the inclined plane will make 30 degree, same angle of inclination with respect to the vertical. We knew this from friction chapter. Anyway, it's a recall to memory from geometry. Now 60 sigma MA equal to 0, it is 60 sine 60 vertically down into 2.5 plus 2 plus 1. 60 sine 60 into 1 plus into 1 plus 80 sine 75 into 3, 2 plus 1 3, 50 sine 60 into 5.5, 2.5 plus 2 4.5 plus 1 5.5 minus RB cos 30. The vertical component is cos 30 because angle is referred with respect to vertical. RB cos 30 into 6. This is the span. So now we will get RB equal to 521.94 divided by 5.91, that is cos 6 cos 30. So that's equal to 100.44 kilonewton. And if we say sigma fx equal to 0, we will just get HA, the horizontal component, plus 60 cos 60 minus 80 cos 75 because it is acting leftwards, plus 50 cos 60 acting rightwards, minus here is a reaction over here, the component of RB. RB is found out to be 100.44, that is 100.44 sine 6, sine 30 it should be. Sorry, it should be sine 30. Yeah. Yeah. HA equal to 52.7 kilonewton. Our assumed direction is correct. Once again, we need to find out VA. For that, we will just say sigma Fy equal to 0. So minus 60 sine 60 coming down, minus 80 sine 75 coming down, 50 sine 60 coming down, plus VA going up, plus 100.44 cos 30. VA is going up, 100.44 cos 30. It will get us VA equal to 85.55 kilonewton. Now, find the support reactions at A and B for the beam loaded as shown. Here a beam is there and it is being loaded with a triangularly varying load of different intensity. This may be a slab, this may be a beam, and over this beam there are two walls constructed in this shape. So this is for maximum, and we need to find out, of course, the equivalent concentrated load. That's it. It becomes similar to the second problem or the very first problem. So this is half 4 into 2, half 4 is the base and 2 is the height. So meter will get cancelled and we will get 4 kilonewton acting exactly over here at a distance of 4 by 3. And here it is half, base is 4 into height is 4. It will get us 8 kilonewton, and the distance of both the forces are at 1/3 of 4 or 2/3 from here. Anyway, it's very easy to calculate this, 1.33 meters. So we are just given three vertical forces at various distances over a simply supported beam. That's all. So the problem will reduce to a very primitive problem. Now VA plus VB, here the reactions are there. There is no chance for any horizontal reaction over this hinge because there are no horizontal forces acting over the system. So sigma MA equal to 0 will give us one of the reactions readily. So VB into 4 plus 4, 8 plus 4 into 1.33, this one clockwise moment, and this is 8 into 6.67 because here till here it is 8 minus 1.33 will get us 6.67 plus 10 into 6. This is 10 and 10 into 6. It is already given 10 into 6 meters. This is a readily available force, that is given force. And this is 6.67 is obtained by lessening 1.33 from 8 because this distance is 1.33. Yeah, we got VB equal to 14.8 and we will apply sigma Fy equal to 0, which is VA plus VB equal to 4 plus 8 plus 10, 22 kilonewton. Therefore VA equal to 7.2 kilonewton. Here none of the forces are to be reversed because our assumed directions of the reactions are correct. Now this is the last problem probably. A pulley supporting 400 Newton is mounted at C over the single overhanging beam. Okay. If the beam weighs 800 kilonewton, which will be acting exactly at the center, find the support reactions at A and B, neglect the weight of the pulley. Now, the same figure, same beam loaded as shown in figure here with all this thread and a pulley and a weight being hung over here can be replaced by a very simple diagram, and here there is a tension. tension acting along the wire, and this tension should be none other than 400 kilonewton. And here the weight of the beam acts exactly at 4.5 meters, because this the total span is 9 meters. This is VA and this is VB, and this is the horizontal reaction at A. There should be horizontal reaction because the tension force is inclined, and there is a horizontal component, that is 4,000 tan theta, 4,000 cos theta, sorry, sin theta, acting in rightward direction. We'll find out this theta by making use of this geometry. And if this were to be theta, then tan theta equal to opposite, that is 4 by 3. 4 by 3. Therefore theta equal to tan inverse of 1.33. That will get us 53.13. That means this angle is 53.13. And all the other forces we have written correctly HA over here, because the force acting is like this, and we are going to prove that this assumed direction is wrong. Anyway, we can always assume the reaction to be always positive in nature, that I told repeatedly in my various tutorials. Right, now once again the figure is written again for the sake of clarity. Now sigma fx equal to 0. Sigma fx equal to 0 will give us 3200, that is 4000 sin 53.13, the component of this tension. Okay, that is positive. HA is also positive, I assume. Therefore HA is going to be negative now because of its negative intensity. It should be reversed, and it should be reversed. It should be changed by another force. Just reversal of the assumed direction. Sigma MA equal to 0 will give us VB into phi, the anti-clockwise moment equal to all the clockwise moments, 3200. Even this will also create a moment because of the moment arm. Moment arm is nothing but the height of this frame itself. So it is 3200 into 3, which is a clockwise moment. So the moment, whether it is clockwise or not clockwise, we should be careful about the sense. So the rotation happens along the sense. So it goes like this. It goes like this clockwise. Plus 2400, that is this one, this component, vertical component, 2400 into phi. This is the moment arm for that, because it will be acting over the beam, through the frame, plus 800 into 4.5. 800 is the self weight given. We should act exactly at the center. The length is 9 meters. Therefore it is available at 4.5 meters. Therefore we have got VB to be 5040 Newton, and Fy equal to 0 will give us VA plus VB equal to 2400, the vertical component of this tension, plus 800, the self weight. It will give us 3200, and when we find out VA, it happens to be negative, because 3200 minus 5040 will give us 1840 in the negative direction. Therefore the VA, the assumed direction, is wrong. Therefore it should be reversed. So with this we have completed the 5th tutorial on non-concurrent force system, with special reference to equilibrium. We have found out support reactions in 2 tutorials, and I think our viewers should be comfortable with this after going through both the tutorials. And if you have liked this video, kindly subscribe to this my channel, and until I come with moment of inertia on center of gravity, the next chapter or next themes to be discussed under engineering mechanics. Until then, bye.